Okay, so now we have first method, arithmetic progression. Generally we call this as a AP. So arithmetic progression means, why we are calling this as a arithmetic progression, what is a special inside this. Okay, so arithmetic progression is the sequence of numbers such that the difference between two successive terms is always constant. Not just constant, is always same also. Whatever the difference will be there in the two consecutive terms, it will be same. If I'll write the odd number or even number, like 2, 4, 6, 8, 10. So if you take the difference of these consecutive numbers, like 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is 2. So the consecutive difference is same. Okay, it is a constant number, and yes, it is same. So whenever we are getting the difference same, okay, and constant, that progression or that series is under the arithmetic progression. Okay, now the difference which we used here, we have the name for that, we call that as common difference. So that is represented by D, common difference. Okay, next part is how the AP will be. Let us suppose the series, I'm taking the A as the first term of my series, and if I'm saying that my D is the common difference, so my next term I can write as A plus D. Again, I will add D in this term, so I can write next term as A plus 2D, then A plus 3D, then A plus 4D, and so on. If it is my infinite series, so I'll just write it so on. If it is a finite series, then I will have one last term, okay, of this series, okay, for the finite series. So what we have here is, so in this case what will happen now, see, common difference, since I said D is my common difference, means the difference between the consecutive terms. So D can be written as A2 minus A1, or else A3 minus A2, or else A4 minus A3, and so on if it is infinite series. And finite series, then we are going to discuss. Now in finite series what will happen is, if I'm moving from A, the first term, till end, so I can write as A plus ND, the last term. Okay, I'll write A plus ND, but what will be my second last term before that? Definitely it will be one less, so A plus N minus 1 into D, where N represents here as number of terms. Okay, so A plus ND. Now the problem here in this series is, mostly student, they will not able to understand this part, as since according to the flow, I wrote here as A plus D, A plus 2D, A plus 3D. So I write this as A plus ND. But if you recognize this as properly, I started D from the second term. Okay, so D plus 2D. So D is going till N. But since I started my first term with the A, so the last term of this series will be A plus N minus 1 into D, not the A plus ND. So my series will go from A plus D, A plus 2D, A plus 3D, A plus 4D, up to A plus N minus 1 into D. Okay, this is my last term. This is not just last term, we have some particular name for this. I will discuss in the next slide, but before that I will discuss the common difference. Now when I talk about the common difference is A2 minus A1. Since I said A plus N minus 1 is my last term, okay, so N means number of terms. If I'll define my D in terms of N, I can define my D in terms of N as An minus of An minus 1, An minus of An minus 1, common difference formula. You put N value as 1, so you'll get as A1 minus A0. If you put N value as 2, you will get as A2 minus A1. So like that you can get all the terms. So this is my common difference formula. Okay, and this is my AP, arithmetic progression series in the under the AP, and we can have many different series. So remember that A is my first term, D is my common difference, so D is my common difference. So these two are the most important, first and the common difference, and here N is known as number of terms. Again, I'm telling you, my last term will be a plus n minus 1 into 2 for finite series. Okay, so we'll discuss about the general term.